Shush, shush. No, they can't hear that. Okay. So it turns out, and you might suspect, that these are very much geometrical problems, right? You guys have done geometry and math. You've probably done some calculations, with Pythagorean theorem, right? You've used Pythagorean theorem. We don't understand what the Pythagorean theorem is. Okay, I'm getting looks that it's like, yeah, of course we do. Okay, so that's good. So you can imagine, if I really broke this picture down, there's all kinds of triangles, there's all kinds of relationships that are going on with angles within these ray diagrams. So it turns out that we can analyze all of these image locations and all of these other exciting things. We can do it mathematically. So not only can we find images and find their properties with ray diagrams, we can also do them with mathematical equations. So what I'm going to do right now is I'm just going to put up a slide that's going to show you what the equations are, and then I'm going to show you a picture of what all these things mean. So at this point, you're writing that all down. You're just writing it all down, and on the next slide, I'm going to show you what they mean, and then I'm going to show you how to calculate them. Oh, are you looking online? You've got to look up here for this, all right? Because the program that I used to generate those mathematical equations, all right, they work well on my PowerPoint, but when I transfer that PowerPoint to Google Classroom, Google does not recognize that thing. So you want to write them down what they look like up here. Okay? Yep. They work for both. You mean converging versus diverging? They work for both. Nope, they work for both. Yeah. And I'm going to explain to you how they work for both. And I was going to do that on the next slide, but I can actually add one more line here. I wonder if it's an animation issue. Curved mirrors. Let's click one more time. Nope. So it's not an animation issue. I'll put it right at the very bottom. I'm going to put two more lines right down there on the bottom. So if you get there on the bottom, you're looking ahead, I'm going to add two more lines there. So we have some variables here, obviously. This is d subscript I. I say di. It's the distance to the image. I have a d subscript O. I say do. And it is the distance to the object. And when we say the distance, we mean from the mirror on the principal axis. This capital M stands for magnification. We haven't talked about that, but again, that's related to size. How many times bigger is it? So then I have HI. I say high. HI. So what we say, high. And that stands for the height of the image. And then we have HO, which I say ho, and it stands for the height of the object. So M is equal to high over ho. It turns out we can also get the magnification from the distances. It's equal to negative di over do, or di over do. If di to the image is negative, it's virtual. So the signs tell us whether it's virtual or whether it's real. If di, the distance to the image, is positive, it is real. If the m is negative, it's inverted. It means it's down on the bottom. And if m is positive, it is upright. Here's where I'm going to add two more things. If F and C are, oops, well, what have I done here? I was thinking about what I was going to write. My eraser doesn't work. Are positive, that's a plus with a VE, stands for positive. If F and CE are positive, it's concave. So the signs of the focus and the signs of the C tell you whether it's concave or not. Okay? So if you've got a concave mirror, F and C will be positive. And if you have a convex F and C, so if F and C are negative, that's a negative sign with a VE, so my lazy way of writing negative, then it's convex. All right? So the signs, sorry, F and R, don't worry about it. Don't worry about it. I'm going to talk about it. Don't worry, there is no C in there. Yep. It says R, and then this says positive, plus with a VE, positive. That's my scientific lazy way of writing positive. Yeah, F and R. Yeah, that's a better way to put it. F and R. I'm writing the points. You're right, and I should be writing the distances. So F and R. F and R. All right? You guys are so picky on the terminology. That's good. I'm doing that on purpose, seeing if you're checking. You're all doing well. Nicely done. It's an old teaching trick. All of my mistakes are on purpose. That goes out to the internet. So parents, don't you worry. Everything's under control. Okay, let me just draw a picture, and we don't need to draw both of these, but let me just kind of represent it here. So remember, let's just draw one of them. Just draw this top one. It doesn't matter which one you draw, but remember, out here is the real world, and our values are positive. So if things are out in front of the mirror, the numbers will be positive. DI will be positive. All right? If the focal length is out in front of the mirror for concave, it is positive. All right? If the focal length is in behind for diverging, it is negative. So again, virtual, I'm struggling with my spelling there. Virtual, again, I'm doing that on purpose. Things will be negative. All right? So if it's on the back side and it's virtual, things will be negative. Okay? And that's how we're going to determine the signs of things. All right? We just finished off one ray diagram for you guys, and there's only one, so we only have to do it the once. Now we're doing some math over here. I'd probably try to catch up to here and worry about that picture maybe later on. You can get that out of the textbook really easily. All right. So again, don't worry about drawing the bottom one, but I'm just reminding us of what convex is. And so again, in behind the mirror, that F would be negative. So if the F is negative, we're dealing with diverging. If the F is positive, we're dealing with converging. My next slide simply has a grid. And what I'm doing here, and you can make this table, and I want you to copy the information down. And this really isn't problem solving. I'm not actually giving you a problem. I'm going to do two more examples after this, and then I'm going to give you a worksheet to work on. But this isn't really problem solving. What I'm teaching you here is how to use your calculators to get the right answers. All right? Yeah, and I apologize for the contrast. It's not that great. I cut and pasted it from a different document. and I realize that it's not awesome. In other words, I'm just giving you a bunch of F's. Oh, look at there. You know what I want you to do? I want you to change this column here. And I should have checked this out. It's not a big deal. H-O-H-I. I want you to change this column to D-O. I want the first column to be the object, and I want the second column to be the image. All right, I want the first column to be the object and the second column to be the image. Oh, you guys will be okay. I want the first, I want F, and then I want DO, the distance to the object, and then we want to find the DI, okay? No, I want you to start with the height of the object, and in the end, we're going to find the height of the image. In other words, I wanted you to start with where the object is, all right? And then we want to figure out the information about the image. We're not switching the other ones. No, I like that. The first one is kind of a mistake, okay? All I did was I changed this DI in this second column to become DO. And I changed this DO in the second column to become DI. And that's the only change I've made. No, now I know what the DO is, and I'm going to find what the DI is. That's what I want to do. I want to find where the image is, just like we did in our ray diagrams. I want to find where the image is, and then I want to find out how tall it is, et cetera, et cetera. And so then I just have a bunch of numbers, 2.5 and 5. Just change the title of the table, people. Don't switch any numbers around. This is the DO, and it's going to go in as DO. This is insanity. I am truly concerned about you, and I'm putting this on the internet. I want to switch this title to DO, and this to DI. We're finding the image. If I just changed the column and the number, I wouldn't have changed anything except its position. That's meaningless. We're finding the image, people. Thank you. We're finding the image. If you've completely switched everything, you gotta find. I'm going to do some math here in a minute. Emma, were you able to solve that problem? You're sitting quietly. Are you waiting for guidance, or are you? Thank you. Thank you very much. Thank you, Martina. You're ready to go? Excellent. Thank you. Question by Josie Marks. Go ahead. 8.0, 3.0. Those are acceptable questions. Sorry? Because I used a different ruler. I used a ruler that had more decimals than the other one when I measured those. That's why some are point and the other ones aren't. Because I used a ruler that could tell me that it was exactly on 5 point. It was exactly on. It was perfect. It was a good number. That's why. Yep. The ruler I used to measure it. Okay, I'm going to continue on. Those of you who are still battling with your table, you'll have to watch the video or something. I don't know. All right. Let's continue. So I want to find here DI in that first example. So I'm going to be writing here an answer on the bottom. You guys can write along. You can call that A. You can call that 1. I don't even know what to do here, but you can call it whatever you want. I'm going to put here 1 because I'm going to work on number 1. And I want to ultimately find the distance to the image, kind of like when we were drawing our ray diagrams, but with math. And the equation is, well, what is the equation? I want to make sure it looks exactly the same as the way you wrote it down because I don't want to mess anybody up. Over, okay, 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 thank you. 1 over di, I heard that, shush, shush. 1 over di plus 1 over do equals 1 over f. Shush, don't ignore them. Let's continue. Let's put in our information. 1 over di is what we're looking for. Plus, we have do, 1 over 5.0 equals 1 over 2.5. Now, I need to find di. If I bring this to the other side, mathematically, what am I doing with that? Subtracting it. Good, I'm glad everybody's with me. So 1 over di is equal to 1 over 5 minus 1 over 2.5. Now, the answer is not 1 over 2.5 because these are fractions, which means we have to subtract them using the rules of fractions. So if we're going to use the rules of fractions, what do we need? A common denominator. Now, everybody stop, because I guarantee right now that half the class who are mathletes, as they say on the announcements, are going, yeah, I love fractions, let's go. And the other half of the class is going, oh my God, we're going to do fractions. Now, stay with me. Everyone pay attention here. What is your question? Sorry, I got it backwards. 1 over di is equal to 1 over 2.5 minus 1 over 5.0. Thank you very much. That's a good fix, because I was worried more about how we're going to make sure we get this right. Thank you. We're going to do this without using common denominators. All right, Mr. Ferguson right now is losing his mind. When he watches this video, he's going to say, what? You got to make them use common denominators. I say no. You need to now look at your calculator, your scientific calculator, and you are going to look for a button that looks like this. It's either going to be 1 over x, or you're looking for the button that says x to the minus 1. Please find that button now. It may be a second function button. Who's found the button? Beautiful. Those of you using your phone are now cursing and swearing that you're using a phone instead of using an actual calculator. Have we found the button? Found the button? Nice. Found the button? Good. Have we found the button? It's either 1 over x or x to the minus 1. That's called the inverse button, all right? And you guys all know that when you take the inverse of something, you're flipping it over. So what we want to do now is we want to take the inverse of 2.5 and we want to subtract it from the inverse of 5. So follow along with your calculators. Here's how it works. Press 2.5. That's 2, then the little dot, and then the 5. Were we all up to speed? Because we had trouble with the table a minute ago. I didn't want anybody to mess this up. We're up to speed here. Now you can press the inverse button. Beautiful. You're an advanced student. Now just wait. That's good. Oh, hold on one second. There's 2 types of calculators in the world, folks. No. This will all work. What is your calculator saying? Oh, I can't see a darn thing. It's solar. Oh, beautiful. It's in good shape. Okay, we're all in good shape. Are we all there? We all got it? Oh, then you're toast. So, are we with me? Now press subtract. Press subtract. You got it? Then press 5 You don't really need the 0.0 as you pointed out, but you could if you'd like, if it makes you feel good. Then press the inverse button again. We got that? Now you're going to press equals, and you're going to tell me what that number is. Now be very careful. That's going to be equal to 1 over di. That's not our answer yet, but I want to know what that number is. Sorry? Oh, I don't want to know a fraction. If your calculator gives you fractions, that's fine. Did yours give you a fraction? What did it give you? Okay. What's the decimal number? 0.2. That's it? 0.2? 0.2. All right? Do we all have 0.2? Nice. Now, that's not the answer. Listen. That's not the answer. That's the inverse of the answer. Okay? Does everybody have an answer button on their calculator? Can you find an answer button? A and S. All right? A and S? It's near the equals. It might be a second function. Okay, now hold on. What we want to do now is we want that answer. You might not even have to press the answer button. Just press the inverse button right now. With that number on your screen, press the inverse button again, and then press equals. It give you a number 5? That's the answer. di equals 5.0 centimeters. Okay? So we had to invert it again. If you messed it up, you can go through it again. Follow along, because you can do it quickly. Let's do this all one more time together as a group. Don't care. Okay, let's keep going. 2.5 inverse. Do that. 2.5 inverse. We're doing it again, but quickly. We're doing this whole thing again. 2.5 inverse. Got it? Minus 5 inverse. Got it? Equals. Got it? Now press inverse. Equals. 5. You inverse the answer because this answer is the inverse of di. So when you inverse the answer, you get di back. Yes. Yes. No, why would you inverse the 5 again? Once you've inverted it, look at this. Once you inverse this, the d is up top, you have your answer. And you get 0.2 again. You're going to get back to where you came from. Then you've screwed that up. You're backing forth. Don't do that. Okay. So we end up with, right here, 5. 5. This was practice. Now we're going to be able to do it really quickly. Okay, shush. Now, M, and I got to clear my screen for a minute, so just be patient. I don't, but I can clear the screen. Yep. Five. M is equal to, listen up, what 2 pieces of information do I have? I've got the di and the do. So I have to use the di and do version, right? Because remember, there's 2 versions for M. One is high over ho, and the other one is negative di over do, right? Notice I've got di and I've got do. Negative di over do. It's the negative of the answer you get. It doesn't matter whether I put that negative on the top or in the middle or on the bottom. It's the negative of whatever I get for the answer of that fraction. In this equation, it is. Let's now put the numbers in. We don't need the inverse button for this. di is 5. do, all right, whoops, that's do is 5. It's negative of what that is. So what's the Magnification. -1. -1. What does the negative mean? The negative, it's virtual, and what else does it mean? It's inverted. It's upside down. Okay? If the height of the object is 1.5 centimeters, high over ho, we now know that that's equal to -1. Why do we know that? Because we know the magnification, and magnification is equal to high over ho and die over do, so, right, with a negative. So therefore, I know that that's HI, the image, over 1.5 centimeters is equal to -1. I need an answer here for HI at this point. It's what I want. I got to multiply both sides by 1.5 as I do my math. Times 1.5 times 1.5. What does that allow me to do? It allows me to cancel that out. I'm just rearranging equations mathematically. So if that's scary to you, go back to, where do you learn this? Grade? No. You do not do algebra in grade 10. You do algebra in grade 8. Sure you do. HI is equal to what? -1.5 centimeters. Folks, Thomas, do you understand this? Is this making sense to you? Okay, all right. All right, so I now have here a magnification of -1, all right? And here the HI is -1.5, all right? If we think about this, if I have a focal length of 2.5, where's the radius? 5. Where was the object? Which is on C. If it's on C, where was the image? It was on C. 5. Except it was upside down. Negative. What was the size of the image when it was on C? When we did the picture yesterday? How big was it? How big was that arrow when we did that yesterday? How big was it compared to the object? Same size. So you'll see here, it's the same size. This is the mathematical relationship if the object is on C. So this is on C. All right, let's do another one. Now, because we are excellent students and we can problem solve here, we should be able to go through this a little quicker. Now, and you flipped it? In that case, you would. But that's the only case, because it was on C. Okay? Let's do the second one. 2. This time I want to get right to the answer without writing out all those equations. I have no idea what he said. I'm keep going. Let's keep going. 1 over. Hey, folks, I'm going to tell you what's happening here. I'm going to explain to you exactly what's happening here. Math makes a lot of people nervous, right? And there's a bunch of you in this room that are hating this. Don't comment. Don't say anything. Typical student response. Let's joke about it. Let's make a joke so that we giggle between every calculation, which means when I give you an assignment and you screw it up, you get to come to me and say, I didn't get it in the first place. It didn't make any sense. So I need everyone to stop. I need you to stop joking. I need you to stop giggling. And I'm going to tell you how to do it. So don't try to sabotage it, because that's what this process is. You're trying to make this funny so that in the end you can say, I didn't get it. It's your fault. So let's just relax. Let's write the equation down. 1 over di plus 1 over do is equal to 1 over s. Let's put our numbers in. di is what we're looking for, 1 over di. This time, it's 15, 1 over 15, all right? And this is 22, 1 over 22. The only math I want you to do in terms of rearranging is bringing this to the other side. And I think we know how to do that. It's going to be subtracted, correct? So 1 over di is equal to 1 over 22 minus 1 over 15. Now at this point, I'm hoping if we use our calculator correctly, we should be able to go, therefore, di equals. So let's go through the steps again. 22, and then what do you push? Inverse. Now you're on your calculator. 22 inverse minus, right? 15 inverse, okay? Equals. Now remember, that's not your answer. That's the inverse of your answer. So you have to press inverse one more time to turn it into its answer. You should have a number staring at you. What number are you looking at? Negative 47.1? Negative 47.1? Negative 47.1? Negative 47.1. Awesome. Centimeters. Negative for di. What type of image is this? If it's negative, what type of image is it? Yeah, it means it's on the back side of the mirror. Notice, the object is in between the focal point and the mirror when we're really close. And that makes a virtual image. Excellent. Let's do the magnification. Negative of di over do, which will be negative of negative 47.1 over 22. What happens to these two negatives? Mathematically, they cancel out. So you could get an answer for your fraction. It's going to be a negative answer, and then the negative of that makes it positive. So because there's two negatives, we can ignore those. Yep, sorry, it is 15. I put the focal length in there. 15. Good call. I put the focal length in that spot. So 47 over 15, what are we getting? Sorry? And the negatives canceled away, right? 3.14. So if the magnification is positive, what type, or sorry, how would we describe the attitude of this? It's upright. And it's actually 3.14 times bigger. So when we want to get the height of the image, m is equal to hi over ho, all right? All I've got to do is take that object height and multiply it by the magnification, all right?
Lenses.
Yeah, well, mirrors before lenses. Nope.
I like doing those diagrams.
Mm-hmm. Right there. You just finished some.
Favorite.
So, we're going to have here, what do we got? We've got 3.14 equals hi. That's what we want to find. And what was the height of the object? 12. So I'm going to bring that up there and multiply it by it. I'm going to bring that up there and multiply it. hi equals. What do you got? 37.7? 37.7 centimeters. It's really big. That's what we expect. Okay? You guys keep filling in your chart. I'm going to do another one with you, but every time I clear the screen, you guys know that it gets rid of all the writing in the chart, so I'm not even going to bother putting that answer in. But you can put that in your chart. Let's jump down. Let's skip a few. Even though you've already made the chart, you can go back and maybe finish that. Let's jump down to the negative 12. Let's take a look at one that has a negative focal length. So I'm going to do that one next. Okay? So we'll call that number 4 when we do our example. So again, I'm going to clear the screen. Clear ink. So I'm going to jump down to number 4. Again, remember I've switched this to O and I. Brings back painful memories, but I'm okay. Notice this time in number 4, the focal length is negative. What type of mirror is this? It's a convex because the focal length is virtual. It's in the negative territory. But we do it the exact same way. Again, hopefully you're not waiting for me. Hopefully we've gotten to the point where maybe you can start to do this yourself. If you're not sure, use a pencil. Again, 1 over di plus 1 over do equals 1 over f. I will sometimes do it the other way around. 1 over f equals 1 over di plus 1 over do. It's kind of the way I usually write it, but it doesn't matter which way you write it. 1 over di plus 1 over negative 12 equals, oh no, what have I done? It's 15. 15. I'm all excited about the negative. 1 over 15, right? 1 over 15 equals 1 over negative 12. All right, that's me. We got it. Bringing that to the other side, it becomes negative. 1 over di equals 1 over negative 12 minus 1 over 15. Again, we should be able to go to di using the inverse buttons. Negative 12, inverse, minus 15. You do have a negative button. It'll look like this. Negative button will look like this, plus slash minus. And the way you'll normally put it in, it depends on your calculator. You'll either press it first and then with 12. No, there isn't. You do. You do. Just gotta find it. Brackets. Oh, there. Yours, the little negative is gone. See? Clear. Negative. You want to write a negative in there, in that little brackets thing. You want to maybe draw a little negative in there. What do we get after we inverse the answer? Negative 12, inverse, minus 15, inverse, then inverse the answer. What'd you get?
For what?
The answer. After you inverse the answer. Oh, I have confidence. Negative 6.66666. Negative 6.7. Way to go, you did it right. Centimeters. Again, negative for the image. What does that tell us? It's virtual. And like I said, for all diverging mirrors, it'll always be virtual. Magnification. Negative di over do. Put that there. Negative di, which is negative 6.7 over, what is the object there? 15. 15. So what is the magnification? Sorry? 1 point something? It can't be 1.1 because that's smaller than that, so it has to be a decimal. Negative, but I've got a negative of a negative, so just 0.4, 0.4, because the equation is negative di over do, and the di was negative itself, right? So that makes a negative fraction, and then I'm switching the sign because I've got an extra negative. So that's 0.4, did we say? 0.4? Yep. How would you like to? There's many ways. Here. No, you don't. You're just doing a fraction there. You're just doing a division. That line there is divided by the two negatives. We're okay with that. Two negatives makes a positive when we're doing so I would just ignore the negatives because I have two negatives in there. That's how I do it. I see the two negatives and I say to myself, two negatives makes a positive, and then I just do the division. That there's a negative in front of it. Yep. Okay, 0.4. 0.4 means it's 0.4 times its original size. 1 would mean the same size. 0.4 means it's a little under half its size. Okay? So let's eventually get the height of the image. M is equal to high over ho, and 0.4 is equal to hi, which is what we want, and the object's height is 25 centimeters, so I'm bringing that 25 centimeters up there, and I'm multiplying it by 0.4, so hi is equal to. Martina, you got a number? What do you got? 10? 10? 10. 10 centimeters. All right? Notice the magnification is positive. What does that tell us about the attitude? What does it tell us about the attitude if the magnification is positive? It's upright. It's upright. All right? It's upright. Now, yeah, let's do one of the last ones. I would have liked to do a word problem with you. Actually, you know what? I am going to do a word problem with you. Let's keep going. Let's do one of the last ones. I'm going to do now number 6. I'm going to do number 6 next. Number 6. Clear on the screen. 0.4 times 25 is 6. I'm going to keep going. Clearing. 0.4 times 25. Is that 10? Not 10? It's 10. It came from here.
0.4 times 25.
Number 6. Number 6. It's going to be a little different this time because we're looking for something else this time. But it'll be this. You're right. It'll be done the same way using the inverse keys. You're right. We're now just subbing in something different. So in this case, we're looking for f. So again, 1 over die plus 1 over do equals 1 over f. Have you completed this already, Thomas? Oh, that's good. So 1 over di, because I made the switch, 15, this is negative, plus 1 over negative 12 equals 1 over f. Now notice, we don't need to rearrange this, but it's the same procedure. 15 inverse plus negative 12 inverse equals, but that's still not our answer yet, so we have to inverse the answer. F is equal to, what do you got? Nothing? You're just staring into space? What do you got? Negative 6? Negative 6? Negative 60? Negative 60? Negative 60 centimeters. Negative 60 centimeters. What type of mirror is this with a negative f? Convex. Convex. It's one of those last ones we did. Magnification. Negative di over do. Negative. I'll do it on this side. Negative, what's di? Di, 15? 15? 15 over negative 12. I don't like that. The negatives are gone. What do we get for magnification? There's something wrong there. DI is 15. DO is negative 12. Well, this is bad to finish off with. I've got a negative object distance. That's the issue. This one, it doesn't, yeah. This one is a screw up. All right, does anybody see why the screw up? We can come up mathematically with a number, but something is wrong with it. What do we get? 1.25. Does anybody see what's wrong with my question here? There's something gravely wrong with it. Yep. Yes. It has to be in front of the mirror. So by sticking a negative in there, we've somehow placed an object in the virtual world of the mirror. Trippy. It's because I changed it at the beginning, and that's a screw up. That's fun. Hold on. Awesome. It's awesome. Okay. We're going to stop that example there. It doesn't matter. By the way, folks, you can see here we can mathematically actually deal with a situation that doesn't make sense. It's giving us kind of kind of silly answers. Now, you guys are all starting to pack up, but I'm going to show you one more thing here. Listen up. All right. Now, my next example. Yes. Yep. My next example was to then do some word problems. Now, everybody just relax. I'm going to do some of these for you at the beginning of class tomorrow, where you have to then pick out the object and image distances in order to answer the questions. If we go to Google Classroom, you will see on today's entry, I have a practice worksheet. The majority of it is word problems. You can try those tonight. Even though I have not officially done an example of word problems, you can read it through and you can try them. All right? All you have to do, and I hope this comes up in before the bell, all you have to do is pick out the distance of the image, the distance, oops, there was a problem with this document. Can you guys see the document on your end? I'm sure you can. So, all you got to do is try to pick out the DI, try to pick out the DO, or try to pick out the F. Use the equations in the same way. They will be homework eventually. So if you can figure out how to do it yourself tonight, that's awesome. The answers are at the end of the question. So you'll know to see if you've got it right or not. I'm just going to stop my recording here for a moment, for a second.